Most materials will change shape when a force is applied to them. Depending on the direction of the force, they will either stretch or compress. Materials are said to have either elastic properties or plastic properties. A material with elastic properties will change its shape when a force is applied and will then return to its original shape when the force is removed. A material with plastic properties will not return to its original shape when the force is removed. As you can imagine, this difference is important when choosing a material for a particular application.
In this experiment, you are going to investigate Hooke's law. Hooke's law says that if you apply a force to a spring, the spring will stretch and the extension produced will be directly proportional to the force applied. In this experiment, you'll need a clamp, a ruler, a Newton meter and, of course, a spring. Clamp one end of the spring to the edge of your workbench. Place the ruler alongside the spring. Then you can pull the other end of the spring using the Newton meter and measure the extension of the spring using the ruler.
Do you remember the difference between the independent variable and the dependent variable? Well, the independent variable is the one you control, and the dependent variable is the one you measure. In this experiment, the reading on the Newton meter is the independent variable, as you control it, and the measurement on the ruler is the dependent variable, as it is the reading you are measuring.
When you start, you'll need to set the end of the spring to 0 on the ruler by moving the ruler. You can then increase the force on the Newton meter by 1 Newton at a time and make a note of the extension using a ruler. Enter the result into a results table. The headings for the columns in your table need to be extension, with units of meters, m, and reading on Newton meter, with units of newtons, n.
When you have sufficient data, then you can draw a graph. You plot the force in newtons on the y-axis and the extension in meters on the x-axis. The graph you draw should be a straight line that goes through the origin. Do remember that it is the extension of the spring that you plot on the graph, not the total length of the spring.
If you extend your spring above the elastic limit, which is marked as point A in the graph on the screen, then the spring will not return to its original length. You'll find that the spring will have been permanently extended by length B.
If your Newton meter records in kilograms, the measurement of mass, then you need to multiply by 10 to convert to force in newtons. The Newton is the SI unit of force. If you have measured the extension in centimeters, then change this to meters by dividing by 100. If you have measured the extension in millimeters, then divide by 1000 to change to meters. Meters are the SI unit of length.